Hi, and welcome to the 10th episode of our Needle Engine Devlog. This time I'm going to talk about the Needle Engine 4.7 release. And by far the biggest and most exciting thing that ships with this release is MaterialX support. MaterialX is an open standard for representing rich materials for both real-time and offline applications. And we're excited that it's now supported in Needle Engine end-to-end. And that means you can export MaterialX from our Unity integration. You can use MaterialX in Needle Engine in the browser, and you can even use MaterialX materials in Three.js. This is an exciting new feature, and we can't wait to see what you build with it. And we're going to cover it in more detail in a separate video. Another important set of changes that has landed in Needle Engine 4.7 deals with progressive loading of meshes and textures. Now, progressive loading has been a part of Needle for a long time. It's one of our core features to bring 3D assets to the web in an efficient way. And it's really, really good at loading assets very fast, very efficiently, keeping them low in both bandwidth and memory usage, and is really something that you want to use in your apps. And in this release, we added more options to control how progressive assets load, how your scene looks while those assets load, and so on. For example, we introduced a loading blur attribute right on the Needle Engine element. And what that does is it blurs your scene until the first set of progressive meshes and textures has loaded. You can see here that when the scene loads, it's blurry for a brief moment, and then the scene appears. And when we zoom in, we can see that further levels of detail are loaded as needed, both for meshes and for textures. And this is exactly the same as happening in this demonstration here, which shows how much faster scenes load when they're using Needle progressive 3D assets. Why you should use progressive 3D is very visible in this demonstration here, where we are pitching our Needle progressive loading versus regularly compressed GLTF files and against uncompressed GLTF files. You can see that when I refresh the page here, the asset using Needle progressive loads in a split second, whereas even a compressed GLTF file takes almost 2 seconds to load and an uncompressed one 3.5 seconds. And that's on fast internet connection. This gets even more pronounced when you're on a mobile device with like slower internet. And the way it works is that Needle automatically creates level of detail, which means we're simplifying meshes, we're reducing texture size, and first only load what's needed to really display the scene. And then when you get closer to a particular part of your scene, you can see that other level of detail meshes start to load. And that process is entirely automatic with Needle. The female character model you see here is part of our bigger efforts of looking at digital humans in the web and how Needle can make it seamless to bring them there in a high quality. And when you have high quality assets, it's especially important that you're using progressive loading, level of detail, and so on, so that pages stay fast and responsive. And you can see that on this page here as well, that when I refresh it, we're getting slightly lower resolution versions first, but we're getting into the page faster. We don't have to wait for the full model to load, for all the high resolution details and textures to load. Sometimes, for example, when you're making a product configurator or similar, you want to wait for a specific level of detail to load before you show the asset to the user. To do that, we're introducing new APIs to await loading of specific level of detail meshes and textures. And that gives you more control in specific applications on how to handle these, when to reveal the scene to a user, when to wait, and so on. Needle Engine also uses progressive meshes under the hood to speed up raycasts. So in your application, you often can click on objects to cause certain interactions. You can interact with the camera and with the scene and so on. We're speeding up all of that by using the lower resolution meshes to raycast against those. And that process is automatic and asynchronous. So when your scene starts, these are created for you automatically. And here we're also introducing new methods to control whether you want to wait for this behavior before raycasts start doing anything, or whether you want to use a slower fallback while meshes load. We're also adding new APIs for camera control so that it's now easier to programmatically access orbit controls in a scene and, for example, rotate the entire scene left, right, up, or down. OrbitControls now expose convenient rotate left, rotate up, pan and zoom methods to allow for keyboard controls, on-screen buttons, and so on to make simple camera adjustments. Of course, if you need more control, you can always directly interact with camera positions and set that. These new APIs are a convenient way for just changing camera angles and so on. As always, you can look at our API documentation to see all the details, the parameters, and so on, and everything you can do. In this release, we have also simplified and improved how the Needle Engine component looks in our Unity integration. This makes it easier to find things like which team you're currently working in, how to start Needle Engine and refresh what's happening in the local website, and how to deploy to Needle Cloud. So all these actions should now be easier to find and a little bit more cleaned up. And that's it for this week's update. As mentioned earlier, the new big thing here is MaterialX export. So stay tuned for the video about MaterialX in Needle Engine.